Hey Flutter devs! Welcome back to Riverpod Mistakes, the series where we fix one common mistake at a time. Today's mistake is sneaky. It doesn't throw compile errors, it doesn't even crash your app, but it quietly makes your UI clunky and your code messy. It's when you put async logic directly inside a plain provider. Here is the problem. A normal provider is not built for async data. If you return a future from it, your widgets don't get the actual data, they just get the future. This looks harmless, right? You fetch a user from repository and return it. But looks closer now. UserProvider doesn't expose a user, it exposes a future user, which means in every widget that depends on it, you will need to call the then or wrap it in a future builder. Suddenly, your clean reactive Riverpod code turns into boilerplate UI hacks. And the worst part, you just threw away one of the Riverpod superpower built in async state handling. So, what is the right way? Now you are using the correct provider type. With FutureProvider, Riverpod automatically tracks loading, error, and success states. Your widgets no longer deal with raw futures. Instead, they receive a sync value, a powerful wrapper that makes your UI reactive and resilient. See the difference? Instead of writing messy.then callbacks, you declaratively say what to show during loading, success, or error. This makes your code cleaner, safer, and way easier to maintain. The checklist here is always match your provider type to the data you expose. Don't return raw future or stream from a plain provider. Use a future provider or a stream provider or for more advanced cases, use async notifier. This mistake is a saddle. It doesn't crash your app and you will not see any compile errors. But it can make your state unpredictable and your debugging a nightmare. It's not disposing providers properly, a silent memory leak waiting to happen. Here's the problem when you create providers that depend on something expensive like a stream or a timers or a database connection, but you never clean them up. Here's the wrong code example. This looks fine, right? You start a timer inside a provider and it works. But here's the problem. Riverpod will not automatically dispose this timer when the provider is no longer used. That means the timer keeps running forever even when no widget needed anymore. The result is memory leaks and unexpected background activity. And the worst part, you didn't even notice until your app starts slowing down or draining your battery. So, what's the right way? The fix is use ref.onDispose. With ref.onDispose, Riverpod automatically cleans up your resources when the provider is no longer needed. No digging timers, no memory leaks, no unexpected behavior. Better alternative, use autoDispose. Adding .autoDispose ensures that when your widget tree no longer watches this provider, Riverpod disposes it automatically. This is especially useful for screens, tabs, or temporary widgets. Now, you can safely watch your provider without worrying about the background leaks or zombie timers. Here's the checklist. Always dispose expensive resources like timers, streams, and controllers. Use rf.onDispose for manual cleanup. Use .autoDispose for temporary providers. Avoid leaking resources when widgets are removed. This mistake isn't obvious. Your app will not crash, but it will rebuild unnecessarily and slow down your UI. It's watching providers in the wrong place. Here's the problem. Putting ref.watch directly inside the widget's build method when you don't need the whole widget to rebuild. Here's the wrong example. Seems fine, right? You are watching the user provider to show the user info. But here's the issue. Every time the user changes, the entire profile screen rebuilds, including settings panel, even if it doesn't depend on user provider. This can cause unnecessary re-renders and sluggish performance. And the worst part, it gets worse when you have multiple providers being watched at the top level. So, what is the right way? The fix here is just use consumer or ref.listen. By moving ref.watch into consumer widgets, only part of the UI that depends on the provider will rebuild. Now, settings panel stays stable, improving performance significantly. Here's the pro tip. Use ref.listen for side effects. Here's a checklist. Don't watch providers at the top of the large widgets. Use consumer or consumer widgets for a fine-grained rebuild. Use ref.listen for side effects, not UI updates. Keep heavy widgets outside the reactive rebuild zone. Are you declaring providers inside your widget files? That's hidden performance bug. Let me show you why. When you declare a provider inside a widget, it gets recreated every time that widget rebuilds. That means new state, lost cache, and performance issues. Here the wrong way inside the widget file, and here the right way, define it once outside any widget. By defining providers outside, they live as long as your app, not just as long as widget rebuild. That means stable state and efficient rebuilds. So next time, don't bury providers inside widgets. Keep them outside for a clean, professional Flutter code. Your Flutter app might be leaking memory right now, and you didn't even notice until it started lagging. Riverpod mistake number 5, forgetting about autoDispose. Let's go. Imagine you have a screen that uses provider to manage some temporary state like a dialog controller, a search filter, or a stepper in a form. You open the screen, interact with it, and close it. What should happen? The provider should be disposed, right? But here's the catch. If you don't mark it as .autodispose, Riverpod will keep that provider alive. That means memory is still allocated, listeners are still attached, and your app is carrying around useless states in the background. Over time, this can lead to the performance issues, especially if you are opening and closing many screens or dialogues. So, what's the fix? Just add .autodispose. Here's an example without autodispose. We may try the search filter provider equal StateProvider, and without autodispose. This works, but the states stick around even after we leave this page. Now, watch what happens when we add autodispose. With this change, as soon as provider is no longer in use, Riverpod disposes of it automatically, freeing memory and cleaning up listeners. So, when should we use autodispose? For short-lived state like a dialogues, forms, or wizard steps. For a screen-specific state that shouldn't serve navigation. For anything ephemeral that doesn't need to persist across your app. But here's an important nuance: don't overuse autodispose. If you want state to persist even when your widget tree is rebuilt, for example, a user login session, app settings, or a cache data, then you shouldn't dispose it automatically. Think of it this way: a formal autodispose, persistent, regular provider. This small habit will save you from countless memory leaks and weird bugs down the road. So, next time you create a provider, ask yourself, should this live forever or should it disappear when unused? If it's the latter, autodispose is your best friend. If you are using Riverpod and have a dozen of tiny providers for every boolean, string, or widget state, you may be turning your app into a debugging nightmare. Here is a mistake I see all the time in the Flutter Riverpod projects, creating too many trivial providers. You might think it makes things modular and clean, but in reality, it makes your app harder to debug and harder to track, and almost impossible to refactor later. Riverpod is powerful because it lets you compose logic, not because you should break everything into tiny pieces. If you have multiple providers that always depend on each other or manage part of the same state, that's a red flag. Instead, group related logic inside a single notifier or a sync notifier. For example, if you have username provider, user email provider, and consider merging them into one cohesive user notifier. That way, your app remains predictable, testable, and scalable. Remember, Riverpod is for composition, not for fragmentation. If your Riverpod UI is not rebuilding, you're probably breaking immutability. And it's one mistake that silently destroys your app state flow. Let me show you the wrong way and the right way and why it matters. Hey Flutter devs, Riverpod is a powerful, but only if you respect immutability. One of the biggest mistakes developers make is mutating the state in a state notifier. And when you mutate, Riverpod will not rebuild your UI. Let's see why. Here is the wrong way to update state. Look closely, the state is being modified directly. This looks innocent, but Riverpod will not detect the change because you never returned a new state object. Riverpod listens for changes using equal comparison. If the state is mutated and the reference stays the same, that means UI will not rebuild. Debugging becomes painful. Bugs appear randomly. Here is the correct way. Return a brand new state instance every time. Now, the reference changes. Riverpod detects the update, your UI rebuilds, everything works as expected. Use a freezed or a manually immutable class. This guarantees no accidental mutation. Always treat a state as read-only. Always return new instance. Never mutate lists or maps, just clone them. Prefer a freeze for scalability. Respect immutability, and Riverpod will reward you with a clean, predictable state management. If your Riverpod tests are flaky, slow, or randomly failing, you are probably hitting real APIs without realizing it, and it comes down to one mistake: not overriding providers in tests. Riverpod is incredibly testable, but only if you override your providers correctly. One of the biggest testing mistakes is forgetting provider overrides, and that leads to flaky tests that lie to you. Here is the mistake. This test looks fine, but it actually hitting the real API. This test depends on the network, real data, and real timing. That means it can fail for reasons totally unrelated to your code. When you don't override providers in tests, test hit real API, test becomes slow, results change over time. CI failures appear randomly. At that point, your tests stop being tests. That become a gambling. The fix is simple. Always override your providers with mocks or fakes. Now the test is fast, predictable, and completely isolated. In widget tests, always override providers at the root using provider scoop. This guarantees your entire widget tree use the fake dependency, not the real one. Always remember, never let tests touch real APIs. Override repositories, services, and clients. Prefer fakes over mocks when possible. Keep override close to the test. Good tests are boring, fast, and predictable, and Riverpod makes easy if you let it. If your Riverpod UI stops updating, this might be why. One of the most common mistakes Flutter developers make is using provider for a mutable state. It looks correct, it compiles, but your UI never updates. This mistake silently breaks your architecture and leads to hours of debugging. In this video, you will learn why this happens, how the Riverpod really works, and the correct way to manage the mutable state safely. The problem in Riverpod, the basic provider is designed for read-only dependency. For example, this is a correct way because the repository itself it doesn't change, but many developers try this. Then later, this doesn't work. Why? Because provider is immutable. Riverpod will never notify the UI, so your UI becomes frozen. Why this happens? Riverpod rebuilds widgets only when state changes are emitted. Provider doesn't emit state changes, it only exposes a value. Think of a provider like a constant reference, not a dynamic state container. It's like reading a number written on a paper. You cannot update it and expect everyone to see that change. The solution? For a mutable state, just use StateProvider. Now update it, Riverpod will notify the UI instantly because StateProvider is designed for a mutable state. For real apps, use NotifierProvider. This keeps logic clean and scalable. Provider is like a book. StateProvider is like a whiteboard. NotifierProvider is like a state machine controlling the system. Use the right tool for a right job. Remember, use provider for repositories, services, APIs, immutable dependencies, and use the StateProvider or NotifierProviders for a UI state, counters, user data, business logic. Follow for more.